In this problem, we're told that there are two forces acting on an object. So here's an object, and we're told that there is a 3 Newton horizontal force acting on it, as well as a 6 Newton vertical force. And what we're trying to do is compute the total force on the object. Okay, so to add force vectors together, we have to place them head to tail. So let me draw over here the 3 again, and I'm going to slide the 6 Newton force over so that the head of the 3 Newton is against the tail of the 6 Newton force, and then I'll draw the vector that represents the sum of these two forces. So this vector in red here is the total force acting on the object. To get the size of that total force, notice that we formed a little right triangle here. And so we can use the Pythagorean theorem to figure out the size of the hypotenuse, and that's going to be the square root of 3 newtons squared plus 6 newtons squared. That's 9 plus 36, 45, square root. So the size of the force, so the magnitude of the force vector, let me call it F, is the square root of 45 newtons. We were also asked to find the angle that this force vector makes with respect to the horizontal. In other words, we want to know that angle theta right there. And just by looking at basic trigonometry, we recognize that the tangent of that angle is equal to the rise over the run, or namely 6 over 3. So therefore, the angle is equal to the inverse tangent of 2.